using a few of those quadrilateral properties, we're going to solve for variables. Okay, so we're going to find the value of each variable. Now, it's assumed that all of these are parallelograms, and that's important. So because they're parallelograms, we should be able to use any of these properties. Okay, so right now, it's important to know what we're dealing with. So in this first picture, we're dealing with consecutive angles. They're not opposite from each other. They're not the same size, so they're not equal. So consecutive angles, we know, are supplementary, meaning they add up to 180. So I'm going to go ahead and take that 2x. I'm going to add it to the 116, and that should equal 180 degrees. Okay, so those are consecutive. So if I subtract 116 from both sides, I get that 2x equals 64, and then you divide by 2 and you get x equals 32. And that's all you'd have to do, right? So let's see how that works for number 4. Let me zoom in a bit. Number 4, you're going to notice there are a couple things going on. So we've got this right here, the 17 and the x minus 8. Let's start with that. So we have opposite sides. And we also have, so that's that one. And then in yellow, we've got opposite angles because they're across from each other. They don't share a same segment. So opposite angles. Oops, shouldn't cross that out. There we go. So opposite sides are equal. Okay, right? Those are equal, and so are opposite angles. So for both of these, we're going to set them equal to each other. So the first one I'll do 17 minus is equal to x minus 8. So that was for the opposite sides. And all you have to do is add 8 to both sides. And you end up with 25 is equal to x. So that's x. So let's do our opposite angles now. So we have 121 equals y minus 21. So just like before, you just got to add that 21 over and you get 142 is equal to y, and you're done. Let's see some others. So let's go to number 5. So now we are dealing with diagonals right here. So that's important to know. So we're dealing with the diagonals. And if you go back and get a little refresher, diagonals always bisect each other. Okay? So just a little note, I'll just remind myself they bisect. Okay? What that means is this x plus 2 from here to this point should be congruent to that middle point all the way to this end point. So I'll start with that one. So x plus 2 has to equal 8. And I'll just subtract 2, so x has to equal 6. Then we'll do kind of the same idea, but now we're doing this 15. So that's from this corner to, or that vertex to the middle point, or the midpoint. And then that midpoint all the way down to the next vertex is the 5y. Those are both congruent. So 15 equals 5y. So I'll divide both sides by 5, and you end up with 3 equals y. And you're done. Let's go ahead and do one more. Same idea, we're once again dealing with diagonals, meaning these two right here have to be congruent. So I can go ahead and say 2x plus 3 has to equal 3x minus 4, and then I can go ahead and solve. So I'm going to subtract 3x. So I get negative x plus 3 equals negative 4. Subtract 3. So negative x equals negative 7. And then divide by negative 1. And you end up with x equals positive 7.